Hey guys, this is Ujjwal Kumar Sen and you're watching Ujjwal Kumar Sen English YouTube channel. So guys, in this video I'm going to share with you some amazing facts, right? So let's get started. So my dear, today we'll learn difference between PMM1 and PMM2 in details. Right? I'm pretty sure after watching this video you will never have any kind of confusion between these two things. I mean these two topics, right? PMM1 and PMM2. So first of all, let's understand about what is the meaning of PMM. Right, its full form basically perpetual motion machine. Right, I'm pretty sure you understand about motion and machine, but many of the students don't understand what is the meaning of perpetual. The meaning of perpetual is what? Never ending. That means keep going, right? So it is, if you will say in English, if you can just translate it, never ending motion machine, right? So it's PMM1. In PMM1 we study, or we got this after first law of thermodynamics, and PMM2 we study after second law of thermodynamics. Well, I was thinking how I can able to make you understand with the help of diagrams, because in thermodynamics one of the difficult thing is that we have to just assume many things, right? So I will show you how it is different and how you can define these two PMM1 and PMM2 terms, right? So let me just consider diagram 1 and diagram 2. 1 is representing PMM1 and 2 is representing PMM2. Let me draw it right away. So I am just drawing a machine, right? Let's say engine, right? Engine. And here also I am drawing another engine, right? So according to this PMM1, we can get continuous work without giving any input heat. We just don't need to put any kind of heat, but we can get continuous work, right? And here, because of this this definition of PMM1, first law of thermodynamics is not existing. That means this definition violates first law of thermodynamics. Practically, it is impossible to design a device which can give us output, continuous output, without giving any input. Okay, even it is not possible in life. If we will not study anything, how could it possible we can tell anything about that topic? If we know nothing about that topic, we cannot tell anything about that topic. It is sure shot. So here in case of thermodynamics also, this concept, the definition of PMM1 violates first law of thermodynamics. Okay, now let's move on to the PMM2. The same full form, perpetual motion machine. It first means first kind, second means second kind. What it is saying basically, right? It states that, or you can say that it is saying it is impossible to design a device which can convert complete heat into work. Even based on this concept, we got few other things also. After we generally study after studying second law of thermodynamics, like Clausius statement and Kelvin Planck's statement. But here we are not talking about those statements. Here we are talking about only difference between these two. So you can see the difference, right? It is saying you don't need to give any kind of input. Even then you will get continuous output. The same here also. Difference is here. You are converting heat into work. 100% conversion is there, but it is impossible to design such device. It is like impossible. Even using Carnot cycle, we cannot get 100% efficiency. by using this. If it is possible, then we can get 100% efficiency, but it is not possible. Again, it is violating, you can say that, second law of thermodynamics. Now I'll ask you one question. I want you to answer that question. I'll answer that question in the comment section. Even I will tell you something about that. That is what is the statement of second law of thermodynamics, or you can say that what is the definition of second law of thermodynamics. Well, thermodynamics we study in two ways. One is in chemistry, another one is in physics. But in mechanical engineering we study thermodynamics, the physics one, not the chemistry one. What is the difference? Well, you will see differences in sign conventions. There are a lot of sign conventions I have seen which we consider as positive in physics, but the same sign convention we consider as negative in chemistry. If you have studied both the subjects, you may confuse sometimes when you were studying in 11th class. Right? Now let me tell you what is the definition. I'm going to tell you simplest definition of second law of thermodynamics. If you know the definition, just pause this video, write down in the comment section. Let's see which definition you know. But I will show you how it works, how second law of thermodynamics works. I will show you in this video. Let's go for it. So, second law of thermodynamics. Second law of thermodynamics. Right. I am considering a rod. This rod is good conductor of heat, so that heat can flow from one point to another point. How it can flow? Because of temperature difference. The same thing we study in second law of thermodynamics, right? In second law of thermodynamics we study about quality of energy, its feasibility, direction. That is why second law of thermodynamics is also known as direction law. You can say that. So I am giving the concept of direction here. So suppose that this is a steel rod, and steel rod is good conductor of heat. So this is made up of steel. Okay. Now what I am doing, I am using some source of heat source, right, by using LPG gas cylinder. LPG means, what is the full form LPG? Liquid petroleum gas, which we use in our domestic purpose. We use generally with this, right, for cooking purpose. So whenever we'll giving heat to one end of this steel, what will happen? The temperature of this portion will increase. Let's say after few minutes, its temperature rises to what? 50 degrees centigrade. Now in India, most of the places in India right now cold time. So steel is good conductor of heat. That means again it will be equilibrium to to the environment, right? It's around 10 degree centigrade. Let's say 10 degree centigrade. Now look at the diagram. One end of the rod is having 50 degree centigrade temperature, another end of the rod having 10 degree centigrade temperature. What is happening now? What will happen? Heat will flow from this side to this side to this side, like this direction, right? So this is known as what? Second law of thermodynamics. So how you can define, how you will write its definition like this. Second law of thermodynamics states that heat always flow from higher temperature to lower temperature. And one more thing, let me tell you how heat is flowing from this place to this place because of lattice vibration taking place inside this rod. And we study about, and what is that lattice vibration? It's a part of conduction. It's a process of heat transfer. There is subject we study in mechanical engineering, also in chemical engineering, that is what? Heat and mass transfer, right? And the same kind of mechanism we can see in case of electricity. How electricity is flowing from one point to another point. That is happening because of potential difference. Voltage, right? Potential difference. But here it is happening because of what? Temperature difference. So there is very similar things we study in case of heat as well as in case of electricity. There is a little bit difference obviously, but many things are similar. If you understand that, you can understand this one also. Right, so I hope so you got my point. So this is the difference between PMM1 and PMM2. I hope so you understand the whole concept, right? So if you want me to create in a video in any other topic of thermodynamics, let me know in the comment section. I'll try to create a video on that topic. And if you are new to this channel, subscribe to this channel, press on the bell icon, like this video, share with your friends, and thank you very much. God bless you all. Bye bye.